Mid-December 1944. A snow-covered forest road northeast of Bastogne, Belgium. American reconnaissance troops from the 31st Tank Battalion moved cautiously through abandoned German positions, cataloguing equipment left behind during the chaotic withdrawal from the failed Ardennes offensive. Among burned-out trucks and discarded ammunition crates, they found something extraordinary. Jagdpanther hull number 3-03018 intact, functional, with its formidable 88mm gun still loaded. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. The massive tank destroyer sat silent in a makeshift camouflage position, its low, sleek profile barely visible beneath hastily cut pine branches. The crew had vanished. No demolition charges had been placed. No attempt had been made to spike the gun or disable the Maybach engine. Through the desperation of Germany's final great offensive collapsing into retreat, German forces had abandoned their most sophisticated tank destroyer for Allied capture. What intelligence officers would discover about this vehicle would fundamentally alter American understanding of German armor capabilities. The Jagdpanther represented the pinnacle of German tank destroyer design, combining the reliable Panther chassis with the devastating 88mm PaK-43 gun, the same weapon that made the Tiger II so feared. Its sloped armor could deflect virtually any Allied tank gun. Its low silhouette made it nearly invisible in ambush positions. Its firepower could destroy Sherman tanks at ranges exceeding 3,000 meters. Yet this fearsome weapon sat abandoned in a Belgian forest, not because it had been damaged in combat, not because mechanical failure had immobilized it, but because its fuel tanks were empty. The story of hull number 3018 would reveal a truth more devastating than any battlefield defeat. Germany had engineered a weapon system so sophisticated, so powerful, so technically advanced that German logistics could not sustain it in extended operations. The contradiction was mathematical and absolute. The Jagdpanther consumed fuel at rates that made strategic mobility impossible. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The path to the Jagdpanther's development began not with German initiative, but with German desperation. By late 1942, German forces on the Eastern Front faced an increasingly grim reality. Soviet 34 tanks and KV-1 heavy tanks outmatched German Panzer III and Panzer IV tanks in both armor protection and firepower. The standard 75mm guns mounted on German medium tanks could not reliably penetrate Soviet armor at combat ranges. German tank crews reported with increasing frequency that they had to maneuver to extremely close ranges, often within 300 meters, to achieve penetrating hits on Soviet tanks. This tactical requirement exposed German tanks to devastating return fire from Soviet guns that could penetrate German armor at twice that range. The mathematics of armored warfare were unforgiving. Whichever side could kill the enemy from greater distance held overwhelming advantage. Germany needed mobile anti-tank capability that could destroy Soviet heavy tanks at extended ranges. The solution seemed obvious. Germany possessed the 88mm flak gun, originally designed as an anti-aircraft weapon, but proven devastatingly effective against tanks when employed in ground combat. Converting this weapon to vehicular mounting would provide the long-range anti-tank firepower that German forces desperately needed. The first attempts proved problematic. The Ferdinand tank, destroyer, later redesignated Elefant, mounted the 88mm PaK-43 gun on a chassis based on the failed Porsche Tiger design. 91 Ferdinands were built beginning in early 1943. The vehicle weighed 65 tons, making it slow and difficult to maneuver. More critically, the Ferdinand initially lacked any secondary armament for close defense. Soviet infantry learned quickly that they could approach Ferdinands from close range and destroy them with satchel charges and Molotov cocktails, because the vehicle had no machine gun for self-defense. The Nashorn tank destroyer mounted the 88mm PaK-43 gun on a chassis combining components from Panzer III and Panzer IV tanks, 494 Nashors were produced from February 1943 through March 1945. The vehicle provided excellent firepower but suffered from inadequate armor protection. The fighting compartment was open-topped, exposing the crew to artillery fragments and small arms fire. Side armor measured only 30 millimeters thick, vulnerable to Soviet anti-tank rifles and heavy machine guns. These limitations convinced German planners that a better solution required a proper chassis, specifically designed for heavy weapons. The Panther tank chassis offered ideal characteristics. The Panther mounted sophisticated torsion bar suspension with interleaved road wheels, providing excellent cross-country mobility. The chassis featured frontal armor 80 millimeters thick, sloped at 55 degrees to provide protection equivalent to approximately 140 millimeters of vertical armor. The Maybach HL2 30P30 engine produced 690 horsepower, adequate to move the 45-ton vehicle at reasonable speeds. By mounting the 88mm Pak 43 gun in a fixed casemate on the Panther chassis, German engineers could create a vehicle combining heavy firepower, strong armor protection, and adequate mobility. The fixed casemate eliminated the weight and complexity of a rotating turret, allowing heavier armor on a lighter vehicle. The lower profile made the vehicle more difficult for enemy gunners to spot and engage. The official designation was Panzerjägerpanther, Tank Hunter Panther. In February 1944, Adolf Hitler personally reviewed a full-size mock-up of the vehicle. Impressed by its appearance and promised capabilities, Hitler simplified the designation to Jagdpanther, Hunting Panther. The name captured the vehicle's intended role as a predator stalking the battlefield, waiting in ambush to destroy enemy armor at long range. Production began in January 1944 at WWII facilities in Braunschweig. Initial production targets called for 160 vehicles per month, numbers that would have allowed Germany to equip multiple heavy anti-tank battalions and provide decisive anti-armor capability. The reality fell far short of these ambitious goals. Allied bombing disrupted production facilities and supply chains. Material shortages, particularly high-grade steel and specialized components, limited output. Skilled labor shortages slowed assembly. WWII produced 268 Jagdpanthers from January 1944 through war's end in May 1945. Maschinenfabrik Niedersachsen-Hannover, MNH, produced 112 vehicles from November 1944 onward. Maschinenbau und Bahnbedarf in Potsdam produced 33 vehicles from December 1944. Total production reached 413 vehicles, barely 2.5 times the original monthly target. This limited production meant Jagdpanthers appeared only in small numbers at the front. Heavy anti-tank battalions, the Schwer Panzerjägerabteilungen, were authorized 45 Jagdpanthers each, organized into 3 companies of 14 vehicles plus 3 command vehicles for battalion headquarters. In reality, these battalions rarely fielded more than 20 to 30 operational vehicles at any given time. The specifications appeared formidable on paper. Combat weight of 45.5 tons placed the Jagdpanther in the same weight class as the Panther tank, heavy enough for substantial armor protection, but light enough for reasonable mobility. Length of 9.87 meters, width of 3.27 meters, and height of only 2.72 meters gave the vehicle a low-profile ideal for ambush tactics. The Jagdpanther stood nearly half a meter lower than the Sherman tank, making it substantially harder to spot at combat ranges. Frontal armor measured 80 millimeters thick on the upper glacis plate, sloped at 55 degrees from vertical. This angle effectively increased armor thickness to approximately 140 millimeters equivalent protection against projectiles striking frontally. The lower glacis plate was 60 millimeters thick at 60 degrees slope, providing approximately 90 millimeters equivalent protection. Side armor measured 50 millimeters thick, adequate protection against light anti-tank weapons, but vulnerable to medium anti-tank guns and tank cannon fire. The gun mantlet received special attention. The Sorkopf, pig's head, mantlet was 100 millimeters thick, providing the heaviest armor on the vehicle. This massive casting protected the gun mount and the vulnerable area where the gun penetrated the frontal armor. Combined with the sloped frontal armor, the Jagdpanther presented nearly impenetrable protection from frontal engagement. The main armament, the 88mm PaK 43/3L/71 gun, represented one of the most powerful tank-mounted weapons of World War II. The designation L/71 indicated that barrel length was 71 times the caliber, providing the extended barrel necessary for extremely high muzzle velocity. Standard armor-piercing ammunition left the muzzle at approximately 1,000 meters per second, giving the projectile enormous kinetic energy. At 1,000 meters range, the PaK 43 could penetrate 190 millimeters of vertical armor. At 2,000 meters, penetration remained sufficient to defeat the frontal armor of any Allied tank in service. Sherman tanks mounting 75mm guns could not penetrate Jagdpanther frontal armor at any practical combat range. The 88mm gun could destroy Shermans from ranges exceeding 3,000 meters, far beyond the effective range of Sherman return fire. This enormous advantage in effective engagement range gave Jagdpanthers the theoretical capability to ambush Allied armor columns, destroy multiple tanks before coming under effective return fire, then withdraw before Allied artillery or air power could respond. German tactical doctrine emphasized exactly this approach. Jagdpanthers were not intended for offensive operations or mobile warfare. They were designed for defensive ambush tactics, using superior range and firepower to bleed Allied armor strength during the advance. Secondary armament consisted of a single 7.92mm MG-34 machine gun mounted in a ball mount on the right side of the frontal glacis plate. This machine gun provided defense against infantry assault, a lesson learned from the Ferdinand's vulnerability to close-range infantry attack. Ammunition stowage included 57 88mm rounds and 600 rounds of 7.92mm ammunition. The crew of 5 included a commander, gunner, loader, radio operator who also served as the machine gunner, and driver. The commander occupied a position on the left side of the fighting compartment with access to vision devices and periscopes for battlefield observation. The gunner sat to the commander's right, operating the main gun through a sophisticated range-finding periscope linked to the gun mount. The loader worked behind the gun, handling the separate loading ammunition that consisted of projectile and propellant charge loaded sequentially. The driver sat in the left front of the hull with vision devices, providing forward observation. The radio operator and machine gunner occupied the right front position. This crew arrangement provided adequate space for each crew member to perform their duties, a significant improvement over the cramped conditions in many German armoured vehicles. The Maybach HL 230 P30 engine, mounted in the rear compartment, was a water-cooled 12-cylinder gasoline engine in 60° V configuration. Displacement of 23.1 litres and weight of 1,200 kilograms represented sophisticated automotive engineering applied to military requirements. Maximum output of 700 metric horsepower, equivalent to 690 imperial horsepower, occurred at 3,000 revolutions per minute. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. Normal operational output was 600 metric horsepower at 2,500 revolutions per minute to reduce wear and extend engine life. This power output provided a power-to-weight ratio of 15.3 horsepower per ton, adequate for the vehicle's weight and intended mission. Maximum road speed of 46 kilometers per hour, approximately 28 miles per hour, gave the Jagdpanther sufficient strategic mobility for repositioning between defensive positions. The transmission was a Zahnradfabrik AK 7200 unit with 7 forward gears and 1 reverse gear. This sophisticated gearbox allowed the driver to select optimal engine speed for various terrain and tactical conditions. The transmission connected to the engine through a drive shaft running the length of the hull. Final drives at the front of the vehicle transferred power to the drive sprockets that moved the tracks. Fuel capacity of 700 litres, approximately 185 United States gallons, required frequent refueling during sustained operations. The fuel tanks were located in the rear compartments alongside the engine. German operating documents specified operational range of 160 kilometers on roads under ideal conditions, approximately 100 miles. Cross-country range was listed as 80 kilometers, approximately 50 miles. These fuel consumption figures immediately reveal the Jagdpanther's fundamental strategic weakness. 160 kilometers operational range on roads meant that a Jagdpanther traveling from Germany to the Eastern Front would consume its entire fuel load multiple times during the journey. Even short tactical movements required substantial fuel resources. Any extended operation required continuous fuel supply that German logistics increasingly could not provide. The mathematics were unforgiving. Road fuel consumption of approximately 280 litres per 100 kilometres, equivalent to roughly 0.78 gallons per mile, matched the fuel appetite of vehicles weighing substantially more. Cross-country consumption reached approximately 450 litres per 100 kilometres under normal conditions. Under combat conditions with frequent acceleration, deceleration and manoeuvring, fuel consumption could exceed 700 litres per 100 kilometres. These consumption rates meant that a Jagdpanther operating in combat could exhaust its fuel supply in distances as short as 100 kilometers, approximately 62 miles. For comparison, Sherman tanks achieved fuel consumption of approximately 0.6 gallons per mile on roads, substantially better efficiency, despite similar operational weight. The Sherman's larger fuel capacity of 175 gallons provided operational range exceeding 250 miles under normal conditions. The strategic implications became clear when German planners calculated logistics requirements for Jagdpanther battalions. Each Jagdpanther in active combat operations required approximately 800 to 1,000 gallons of fuel weekly, assuming continuous tactical employment. A battalion of 45 Jagdpanthers theoretically needed 36,000 to 45,000 gallons weekly just for the primary vehicles, not including support vehicles, recovery equipment, fuel trucks, and administrative vehicles essential to battalion operations. When support vehicles were included, German heavy anti-tank battalions equipped with Jagdpanthers consumed fuel at rates exceeding American medium tank battalions, despite fielding less than half as many primary combat vehicles. Impossible logistics burden for German supply systems already strained by Allied air interdiction and shrinking petroleum production capacity. Germany produced approximately 6 million tons of synthetic fuel annually by 1944 through the hydrogenation process that converted coal into liquid petroleum products. This represented barely 1/10 of American petroleum production. Allied strategic bombing systematically targeted synthetic fuel plants throughout 1944, reducing German fuel production by approximately 60% between May and September. By late 1944, fuel shortages affected every aspect of German military operations. The first Jagdpanthers reached combat units in late June 1944, when Schwer Panzerjägerabteilung 654 received 12 vehicles. The battalion deployed to Normandy to counter the Allied invasion that had begun on June 6. German commanders viewed the Jagdpanther as a potential war-winning weapon that could blunt Allied armoured advances and inflict casualties so severe that Allied commanders would reconsider offensive operations. The Jagdpanther's combat debut demonstrated both its extraordinary tactical capabilities and its crippling strategic limitations. On July 30, 1944, 3 Jagdpanthers from Abteilung 654 engaged a squadron of Churchill tanks from the British 6th Guards Tank Brigade near Street Martin de Bois. The engagement lasted approximately 2 minutes. 11 Churchill tanks were destroyed. The Jagdpanthers suffered no losses. This devastating display of firepower and armour protection validated every specification German engineers had promised. At engagement ranges exceeding 2,000 metres, the Jagdpanthers could destroy British tanks with impunity, while remaining effectively invulnerable to return fire. British tank commanders reported that their 75mm guns could not penetrate Jagdpanther armour even at close range. Only the 17-pounder gun mounted on Sherman Firefly tanks offered any possibility of penetrating Jagdpanther frontal armor, and even that weapon required near-perfect shot placement at close range. However, the tactical success masked strategic failure. Within 3 days of this engagement, 6 of the 12 Jagdpanthers in Abteilung 6-5-4 were immobilized, not from battle damage but from fuel shortages. German supply convoys attempting to deliver fuel to forward units faced constant Allied air attack. Allied fighter bombers roamed freely over Normandy during daylight hours, destroying any vehicle movement detected on roads or trails. German units learned to move only at night, but this imposed severe operational restrictions. Night movement was slower, more difficult to coordinate, and placed additional stress on mechanical systems. Drivers had to operate with minimal lighting to avoid detection, increasing the risk of accidents and mechanical failures. Fuel trucks that should have made 3 delivery runs per day could manage only 1 under these conditions. Battalion war diaries captured after the Normandy campaign documented the deteriorating situation with bureaucratic precision. The diary of Schwer Panzerjäger Abteilung 654 shows July entries reporting excellent combat results, but chronic fuel shortages. August 1st entry noted that battalion operational strength had fallen to 8 Jagdpanthers from the original 12 due to fuel exhaustion and mechanical failures. Fuel allocation from division headquarters provided enough fuel for defensive operations only, with no reserves for counterattacks or repositioning. August 10th entry reported that Allied aircraft had destroyed 2 fuel trucks en route to the battalion, eliminating the day's fuel delivery entirely. 4 Jagdpanthers sat immobile, awaiting fuel. The remaining 4 operational vehicles were restricted to static defensive positions because insufficient fuel existed for tactical movement. The entry concluded with a note that the most powerful anti-tank weapon in the German arsenal was effectively useless because it could not move. August 20th entry captured the final collapse. Allied forces had broken through German defensive lines. Orders came to withdraw immediately or face encirclement. Battalion fuel supplies consisted of approximately 2,000 litres, enough to move perhaps 4 Jagdpanthers approximately 50 kilometres. The remaining vehicles would have to be destroyed in place. Demolition teams worked frantically, but time and explosives proved insufficient. Some vehicles would inevitably fall into enemy hands intact. This pattern repeated across every theatre where Jagdpanthers deployed. The vehicles performed superbly in tactical combat when fuel existed and operational conditions allowed their employment. But fuel rarely existed in adequate quantities, and operational conditions grew steadily worse, as Allied air superiority became absolute. The magnificent weapon system could not overcome the fundamental logistics failure that left it immobilized more often than operational. The Battle of the Bulge in December 1944 represented Germany's last major offensive operation in the West. German planners assembled forces for a desperate attempt to split Allied armies, capture the port of Antwerp, and force a negotiated peace in the West before the final Soviet offensive overwhelmed Germany from the east. 5 panzer armies would attack through the Ardennes forest, recreating the successful offensive route of 1940, when German armour had broken through this same terrain and conquered France in 6 weeks. The offensive required enormous fuel resources. Each panzer division needed hundreds of thousands of gallons for the planned advance from the German border to Antwerp, a distance exceeding 200 kilometers. German logistics officers calculated fuel requirements and delivered devastating news. German stockpiles contained enough fuel for approximately 150 kilometers of offensive operations. Beyond that distance, German forces would need to capture Allied fuel dumps to continue the advance. This plan assumed that Allied forces would not destroy fuel dumps during withdrawal, an assumption that proved catastrophically wrong. But German commanders had no choice. The strategic situation demanded offensive action regardless of logistics constraints. Fuel allocations were calculated to the litre. Every vehicle received precisely enough fuel for the planned movement, with no reserves for contingencies. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. For the Ardennes offensive, German planners allocated 27 Jagdpanthers from available stocks, intended to reinforce 5 heavy anti-tank battalions. These battalions were supposed to provide mobile anti-tank capability to counter expected Allied armoured counterattacks. Only 17 Jagdpanthers reached their units before the offensive began on December 16, 1944. The remaining 10 were delayed by transportation problems, fuel shortages, preventing their movement to staging areas, or mechanical failures during the approach march. Hull number 303018 was among the 17 that reached forward units before the offensive. Manufactured by Maschinenfabrik Niedersachsen Hanover in late November or early December 1944, the vehicle was a late production model incorporating several improvements over earlier variants. The hull featured simplified construction methods that reduced manufacturing time. The gun mantlet was the larger bolted design rather than the earlier welded version. Zimmerit anti-magnetic paste was not applied, as German High Command had discontinued this time-consuming process. In September 1944, the vehicle was assigned to a Schwer Heeres Panzerjägerabteilung, one of the Army heavy tank destroyer battalions supporting the offensive. Battalion records that survived the chaotic final months of the war show that this particular Jagdpanther entered combat on December 17th, the second day of the offensive. The battalion war diary notes engagement with American armour near Malmedy, with 2 Sherman tanks destroyed at ranges exceeding 2,000 metres. The Jagdpanther suffered no damage and withdrew successfully to a secondary position. December 20th entry reports fuel situation deteriorating rapidly. Initial fuel allocation consumed during the first 4 days of offensive operations. Promised resupply has not arrived. All vehicles restricted to minimum movement. Offensive operations impossible without fuel delivery. December 23rd entry documents the crisis. No fuel delivery received for 3 days. Allied air attacks have destroyed multiple supply convoys. Battalion ordered to continue advance but lacks fuel for movement. Vehicles positioned defensively awaiting Allied counterattack. Fuel sufficient for perhaps 2 hours of combat operations, after which all vehicles will be immobilized. This entry captures the fundamental contradiction of German operations in late 1944. Orders demanded aggressive offensive action, while logistics realities made such action physically impossible. Tank commanders could not conjure fuel from thin air. The most sophisticated tank destroyer in the world became an immobile pillbox when its fuel tanks ran dry. December 27th entry provides the final notation regarding hull number 303018. Allied forces launched major counterattack. Battalion ordered to withdraw to avoid encirclement. Fuel supplies exhausted. Multiple vehicles, including Jagdpanther 303018, abandoned due to empty fuel tanks. Demolition. Impossible due to time constraints and Allied pressure. Crews evacuated on foot. American forces from the 31st Tank Battalion discovered the abandoned Jagdpanther on December 28th during reconnaissance operations northeast of Bastogne. Initial inspection revealed the vehicle in remarkably complete condition. The main gun remained loaded with an armour-piercing round chambered and ready to fire. The engine appeared functional with no visible damage. Tool stowage, spare parts, and equipment were still aboard. The only missing items were personal crew belongings and classified documents. What puzzled American intelligence officers was the apparent lack of combat damage. The vehicle showed no hits from anti-tank weapons, no penetrations, no evidence of fire or explosion. External inspection revealed paint wear consistent with normal operations, but no battle scars. The conclusion was inescapable. This fearsome weapon system had been abandoned not because it was damaged, but because it was empty. The recovery operation demonstrated the Jagdpanther's extraordinary weight and size. American M32 tank recovery vehicles were designed to recover 30-ton Sherman tanks. Moving a 45-ton Jagdpanther required multiple recovery vehicles working together, plus additional heavy equipment. Engineers assessed the route from the capture site to the nearest American logistics base, checking every bridge for load-bearing capacity and every road for structural integrity. The convoy moved primarily at night to avoid possible German artillery observation, though by late December 1944, German artillery was largely silent due to ammunition shortages. The journey, normally requiring 6 hours, required 2 days. At the logistics base, engineers conducted preliminary inspection before arranging transport to a port facility for shipment to the United States. Colonel George B. Jarrett, chief of the Foreign Material Branch at Aberdeen Proving Ground in Maryland, received notification in early January 1945 that American forces had captured an intact Jagdpanther. This represented an unprecedented intelligence opportunity. Allied forces had fought Jagdpanthers in Normandy, but had captured only damaged vehicles unsuitable for comprehensive testing. An intact functional vehicle would allow detailed evaluation of Germany's most sophisticated tank destroyer. Loading the Jagdpanther aboard a Liberty ship at Antwerp presented significant engineering challenges. The combined weight of vehicle and shipping cradle exceeded 50 tons, requiring heavy lift cranes and specialized loading equipment. Port engineers worked carefully, knowing that the Jagdpanther represented intelligence value far exceeding its weight in captured equipment. The vehicle was secured aboard Liberty ship SS James B. Weaver for Atlantic crossing in late January 1945. The voyage took approximately 3 weeks, with the ship arriving at Norfolk, Virginia, in mid-February 1945. From Norfolk, hull number 303018 travelled by special reinforced flatbed railcar to Aberdeen Proving Ground in Maryland, arriving in late February. Aberdeen Proving Ground served as the United States Army's premier testing and evaluation facility for ordnance and armoured vehicles, exactly as it had when testing Tiger 712 and captured Panthers. Engineers and intelligence officers had prepared for months, studying captured German technical manuals, translating operating documents, and compiling battlefield intelligence reports from units that had encountered Jagdpanthers in combat. Brigadier General Gladion M. Barnes, Chief of Research and Development for Army Ordnance, sent explicit instructions. The captured Jagdpanther represented opportunity to evaluate Germany's most advanced tank destroyer in comprehensive detail. Testing would cover armor protection, armament effectiveness, mechanical reliability, mobility, characteristics, and, critically, logistical requirements, including fuel consumption and operational range. Initial inspection revealed sophisticated German engineering throughout the vehicle. The interleaved road wheel arrangement with torsion bar suspension provided excellent weight distribution and cross-country performance. The 7-speed transmission allowed precise speed selection for various terrain conditions. The famous 88mm PaK-43 gun could fire armor-piercing rounds at muzzle velocities exceeding 1,000 meters per second with exceptional accuracy. The armor protection impressed American engineers even more than earlier German vehicles had. Frontal hull armor measured 80 millimeters thick at 55 degrees slope, providing protection that no American tank gun could penetrate frontally at any range. The gun mantlet measured 100 millimeters thick, making it effectively impervious to anything short of heavy anti-tank guns or artillery. This armor protection validated battlefield reports that Jagdpanthers could only be destroyed reliably by flank shots, artillery fire, or air attack. However, Aberdeen engineers noticed something in German technical specifications that demanded immediate attention, exactly as they had with the Tiger tank. Fuel capacity and consumption figures raised serious questions about the Jagdpanther's operational sustainability. The vehicle carried 700 litres of fuel in tanks located in the rear compartments. German operating documents specified operational range of 160 kilometres on roads under ideal conditions. Cross-country range was listed as 80 kilometres. These figures concerned American engineers familiar with Sherman operational ranges. Even accounting for the Jagdpanther's considerable weight, the operational range seemed dangerously short for a vehicle intended for mobile warfare. More critically, combat experience from Normandy and the Ardennes suggested that actual combat consumption far exceeded the conservative figures in German specifications. The testing program at Aberdeen ran from March 1945 through July 1945. 4 months of intensive evaluation covering every aspect of Jagdpanther performance. Fuel consumption testing received highest priority because it directly affected operational capabilities and explained the mysterious pattern of abandoned Jagdpanthers found across Belgium and Germany. Tests on paved roads at steady cruising speed confirmed German specifications. Hull number 303018 consumed approximately 280 litres per 100 kilometres on roads, equivalent to roughly 0.78 gallons per mile. This gave theoretical maximum range of approximately 210 miles, with full 185-gallon fuel capacity, closely matching German claims when corrected for American gallon measurements versus German litres. However, cross-country testing revealed dramatically worse fuel consumption. Aberdeen's rough terrain course included hills, mud, sand, water crossings, and obstacles simulating combat conditions. Test runs over 50-kilometre courses with varied terrain consumed 450 litres, leaving only 250 litres remaining from the original 700-litre fuel load. This represented fuel consumption of approximately 1.4 gallons per mile, reducing operational range to approximately 130 miles under realistic cross-country conditions. Combat simulation tests produced even more alarming data. When test crews performed realistic combat tasks, including rapid acceleration and deceleration, frequent directional changes requiring pivot turns, turret traverse operations, extended idling periods simulating observation, and intensive radio use, fuel consumption reached approximately 2.2 gallons per mile. Under these intensive combat conditions, operational range fell to approximately 84 miles before fuel exhaustion. The test results painted a devastating strategic picture identical to what Aberdeen engineers had discovered about the Tiger tank. The Jagdpanther, while supremely capable in direct combat, could not sustain extended mobile operations. Its massive fuel appetite demanded continuous resupply in quantities that would strain any logistics system. Under combat conditions, a Jagdpanther battalion would require enormous fuel deliveries simply to remain mobile. Aberdeen engineers calculated the logistics burden using methodologies developed during Tiger testing. Each Jagdpanther in active combat operations required approximately 800 to 1,000 gallons of fuel weekly, assuming continuous tactical employment with daily movement and combat. A battalion of 45 Jagdpanthers needed 36,000 to 45,000 gallons weekly, just for the primary vehicles themselves. Support vehicles added substantial additional requirements. Each battalion required fuel trucks for delivery, recovery vehicles for disabled equipment, reconnaissance vehicles, half-tracks for infantry support, and administrative vehicles. Total battalion fuel consumption reached approximately 70,000 gallons weekly when all vehicles were included. This matched the fuel requirements of an entire American tank battalion, with more than twice as many primary combat vehicles. Colonel Barnes compiled Aberdeen testing data into classified intelligence reports distributed to all Army Armour Commands in August 1945, shortly after Germany's surrender in May. The reports emphasized that Jagdpanthers possessed formidable combat capabilities, including armor protection superior to all Allied tanks and main armament effective beyond 3,000 meters. However, critical vulnerability had been identified. Fuel consumption limited operational range to approximately 160 kilometers under ideal road conditions, reduced to 80 to 100 kilometers under realistic combat conditions. The reports concluded that German logistics could not provide continuous fuel supply adequate for sustained Jagdpanther operations, especially under Allied air interdiction. Immobilized Jagdpanthers could not fight. The vehicle's tactical superiority became strategically irrelevant when fuel shortages left battalions unable to maneuver. This explained the puzzling battlefield pattern of abandoned Jagdpanthers found across Europe, often showing no combat damage but always having empty fuel tanks. Intelligence officers cross-referenced Aberdeen data with captured German supply documents, revealing the full scale of Germany's logistical nightmare. The analysis showed that German logistics in 1944 and 1945 could barely support Tiger and Panther fuel requirements under favorable conditions. Adding Jagdpanthers to the logistics burden created impossible demands on supply systems already failing under Allied air attack and shrinking fuel production. The Jagdpanther's fuel consumption explained operational patterns Allied intelligence had observed throughout late 1944 and early 1945. German heavy tank destroyer battalions rarely operated more than 30 to 50 kilometers from established supply bases. Jagdpanthers avoided prolonged movements when possible, positioning defensively and waiting for Allied forces to advance into engagement range rather than maneuvering actively. This was not tactical preference, but logistical necessity imposed by limited operational range and unreliable fuel supply. Captured German unit war diaries from the Ardennes offensive confirmed the analysis comprehensively. Multiple battalions reported identical problems. Excellent combat performance when engaged, with kill ratios often exceeding 10-1 against Allied armour. But combat engagements, lasting only hours or single days before fuel exhaustion forced cessation of operations. Then, days or weeks of immobility, waiting for fuel deliveries that arrived sporadically or not at all. January 1945 entries from Schwerheerespanzerjägerabteilung 563, operating on the Eastern Front, documented the same pattern. January 15th entry reported engagement with Soviet armour near Warsaw. 53 Soviet tanks destroyed for loss of 1 Jagdpanther to enemy fire and 4 Jagdpanzer IV tank destroyers damaged. Outstanding tactical success. However, fuel supplies exhausted after 8 hours of combat. Battalion immobile awaiting fuel trucks. January 23rd entry reported fuel allocation reduced by half with orders to conserve fuel strictly. Jagdpanthers restricted to static defensive positions, only with no offensive operations authorized until fuel situation improved. The entry noted bitterly that the best tank destroyers in Europe sat idle for want of fuel, while Soviet forces advanced virtually unopposed through sectors where Jagdpanthers could have inflicted devastating casualties if only they could move. February 8th entry reported 3 Jagdpanthers abandoned during withdrawal from defensive positions around Lodz. All were mechanically functional but had empty fuel tanks with no fuel available for movement. Demolition charges were placed, but crews were uncertain if detonation succeeded before Soviet forces overran the position. Crews evacuated on foot, carrying only personal weapons and essential equipment. British intelligence shared captured documents showing identical patterns in Italy and on the Western Front. Every theatre told the same story of tactical excellence crippled by strategic logistics failure. The most sophisticated tank destroyer ever built spent more time immobilized awaiting fuel than engaged in combat operations. American intelligence distributed tactical guidance based on Aberdeen findings to all combat units by September 1945, after the war in Europe had ended but while operations continued against Japan. The guidance served dual purposes, documenting lessons learned from the European campaign and providing intelligence foundation for anticipated operations against Japan, where German armour technology might appear through technology transfer. The guidance advised that when encountering Jagdpanthers, units should avoid direct frontal engagement when possible. The vehicle's armour protection made frontal penetration essentially impossible for standard American tank guns. Instead, manoeuvre to force Jagdpanthers to reposition. Each kilometre a Jagdpanther moves consumes significant fuel reserves. Extended manoeuvring exhausts fuel supplies rapidly. Once immobilized, Jagdpanthers can be bypassed or destroyed with artillery and air support rather than risking direct tank engagement. Training materials produced in late 1945 incorporated fuel consumption findings into broader lessons about German armour. One training film, titled Understanding German Tank Destroyers, explained that the Jagdpanther consumed approximately 2.8 litres per kilometre on roads, increasing to 4.5 to 7 litres per kilometre under combat conditions. Sherman tanks consumed approximately 2.3 litres per kilometre under most conditions. This meant American tanks could manoeuvre nearly twice as far on equivalent fuel under combat conditions. The training materials instructed American tank crews to use their mobility advantage by making Jagdpanthers chase American formations, burning scarce German fuel, then striking when Jagdpanthers could no longer maneuver effectively. The same tactical doctrine developed against Tigers applied equally to Jagdpanthers. Superior German firepower and armor protection could be neutralized by exploiting inferior German operational range and fuel logistics. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.